Hello and welcome guys. So I'm starting a new project playlist and this is the first video of this playlist. In this video we will discuss at the high level what we are going to perform in this entire project. So we are going to build a music genre classifier. So before moving forward, first let me show you the data set. So I have already given the link of this data set in this notebook, and also I will provide the link of this data set in description of this video. Okay. So let's go to the data set. So this data set we are going to use in our model. So this is a GTZan data set. First, this data set is dedicated to build some music genre classifier which can differentiate one sound from another by learning some features from that sound. In this data set we have two directories. First one is this genre original and second one is this images original. This genre original contains 10 genres with 100 audio files each, and all the files is having length of 30 seconds, and second directory contains visual representation of each audio files. This is one way to classify data. We can use this image directly and build some convolutional neural network model, as we have done in our last project in which I have built a plant disease detection system. So there I have used simply the plant disease image and build a classifier. Okay. So they have also provided some images of the features extracted from this audio file, and they are giving us images so that we can take those images and build a classifier on the top of that. But we are not going to do those things here, because if we got all the features, then it's easy to build some image recognition system. But here what we are going to do, here we will take this audio file and we will try to build classifier using this audio file. And also they have given here two CSV file. So what they are doing, they are splitting those 30-second file in 3 seconds. So this way they are increasing the data set by 10 times. So 30-second audio, if we chunk it to 3 seconds, then we will get 10 training example for that 30-second file. So by doing this, we can increase the data set size 10 times. Okay. So they are taking those steps and pre-processing and building some CSV file. So let me show you the data set first. I have already downloaded the data set. So you can download the data set from here. Okay. So let me show you first the data set. So this is a music genre data set. So this is first genre original, this is images original, and these are two files. Okay. So first let me show you the genre original. So inside this we have this 10 directory. These are 10 classes, and blues, classical, country, disco, hip hop, jazz, these are some music genre. Okay, if I go inside this blues, then you will see this some files here. Okay, if I go inside this rock, let me play some file for you. Let me play some pop music here. So these are some data set. So you can download this data set and explore. So these are basically all the musics are inside these folder. Inside this blues, all the blues music are there. All the classical musics are inside this one, and all the rock music inside this. So like that they have structured this data set. And second one is this one, images original. Inside this we have this images of this Mel spectrogram. What is this? I will explain you later. So basically you can think of it like it is some feature extracted in the form of graph. So this is the graph of that sound. Okay, like here blues 000. If you go in this genre original blues, this one, for this file, okay, for this file, if you go inside this is the PNG. Okay, so this is a graph for that file. Okay, so here if you see, these are from 0 to 99. So for all that 100 files, this is a 100 graph for each of those files. Okay, similarly we have a graph for this classical one. This is a Mel spectrogram for classical one. What they are saying that if you are not able to extract the feature, then you can directly take this image, this all the genre image from here and make a image classification model, just like we have built for our last two projects like First one is plant disease, and second one is that fruit and vegetable recognition system. So we have this image, we can directly build a classifier on the top of that. But we are not going to do these things. We will generate these things. We will not use whatever they have provided. And also I will show you this one feature 3 seconds. If I open this file, okay, so let me zoom out this to 75. Okay, so these are some feature, like this is a file name, and this is a length of those files. This is a some chroma stft. This is some type of feature for this audio. Okay, so they are applying some metrics and also calculating their mean. So this is that, and RMS mean they are calculating, spectral centroid mean. These are some terms. If you have idea of signal processing, then you will be able to understand these things. Okay, if you have no idea of signal processing, then also fine, I will explain you each and everything. This is not important for us. Just I am showing that by using these things also we can create some feature, some algorithms they are using to generate this chroma stft, RMS mean they are generating. So these features they are creating. Okay, these features they are creating, and also there is label. So we can use this CSV file and build image, build a classifier, but we are not going to do those things here. So we will not use this CSV file and this image. We will only use this genre original. We will only use this raw audio, and we will try to build a classifier by using this raw audio, so that later if we are going to test this model, then we will simply take any audio and we will feed to our neural network, and neural network will give us a response that out of this 10 genre, what neural networks is predicting that out of this, which one is highly probable for this audio. Okay, and later we will also build a web application, and there also we will simply give a raw audio file and we will try to get prediction from our model. Okay, so that's why we will use only this audio file. We will not use this image and we will not use these features. Okay, and by using this audio file we are going to make a classifier. That's why the project name is music genre classifier, in which it's using some music data and we are going to build some classifier by using those music data. Okay, so I hope you got about the data set. What is the structure of the data set? You have seen the structure of the data set. So now let me explain you what we are going to perform step by step in this project. Okay, so this entire thing I will write each and every line of code and I will explain you in detail. Don't worry, this is just an introductory video. So first step we will do, we will import all the required libraries which is being needed for us to build this classifier, and later if some libraries is needed then we will import. Okay, and then what we are going to perform here, first we will visualize this audio. We will take a random audio, like here I am selecting this blues, this first file. Basically it's if you go inside this genre original, I have already, if you see this my directory, then I have already moved those genres original here, and I also have some test music which I have downloaded from the internet, and these are some files, and this blues.wave I have taken from here, from this folder, and also jazz and these things. So what I am doing, I am taking any random file from our data set and I am trying to visualize those files here so that I can understand that exactly what is the pattern of those files. Okay, to load any audio file I am going to use Librosa library. I will explain you about Librosa and all the things in detail, don't worry. So here we are seeing this visualization, and then also like here I have selected this blues. So by using this ipython.display I am trying to play those. This is the audio of this blues, this one blues.wave. I will explain you later exactly what we are doing here. So we are visualizing and seeing that this is very this graph is very fluctuating. Like if you see, it's looking like noise. Okay, as I already said in the when I am explaining about the data set, that this data set is 30-second long. If you see here, this is 30-second long. So what we are doing here, we are we are splitting those data into 4 seconds here, and also we are taking some overlap duration. I will explain you each and everything, don't worry. And this entire thing I have written, like what we are doing here, we are taking 4-second window, and then we are moving 2 seconds forward by taking 2-second overlap here. Okay, so we are moving 2 seconds forward, and then we are selecting 4-second window, and then we are moving 2 seconds forward, so that we are also maintaining here 2-second overlap. Okay, so like that we are doing here. This code I have written in that way. I will explain you, don't worry, each and everything. And then I have visualized those 4-second data here. Okay, those 4-second data I have visualized here. If you see, this is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Why 15? Because here we are taking 2-second overlap, so basically we are moving 2 second. That's why this 30-second, if we are moving 2 second, then it becomes 15 into 2, 30-second. Okay, that's why here we are getting 15 graphs. Okay, here we are taking 4-second window size and 2-second overlap we are taking, and trying to visualize those chunks. Okay, that's why here I have written doing visualization on chunks of audio. So if you see these chunks, then you will see that this is more good as compared to this one. This is looking like a noise, and if we feed directly this thing to our neural network, then definitely our accuracy will suffer, because by seeing this you can't say anything like what is the pattern in this audio. Neural network can't say anything, because at last we are going to feed some image to our neural network. Okay, that's why they have given here image. In the data set also they have given some image. So basically we are going to, at last we are going to build some MEL spectrogram graph, so that we can feed those graphs to the neural network, and neural network will learn from those graphs and understand that, okay, so this is a MEL spectrogram of blues, this is a MEL spectrogram of classical. So something like that we are going to perform here. Okay, so if you see this chunks, then this is more good as compared to this one. This is looking like a noise. By using this, neural network can't understand it better. Okay, so that's why we are splitting it into chunks, so that neural network can understand it better. Okay, so by doing this experiment we see that, okay, so it is good. If we use this thing, then it is good. Again, it is a tuning parameter, so we can tune and check on some different thing. But I have experimented a lot, and I got this chunk duration 4 and overlap duration 2 on this thing. On this value I got a very good result. Okay, and after that what we will do, after that we will perform a visualization of MEL spectrogram. So here we are going to plot a 2 MEL spectrogram. First one is for entire audio. Here we are plotting MEL spectrogram of entire audio, and here we are plotting MEL spectrogram for those chunks. For these chunks we are plotting the MEL spectrogram. Okay, and then we will see there's some difference. Okay, this is if I show you the MEL spectrogram of each chunks. So this is a MEL spectrogram of each chunks. If first, second, third, all 15 MEL spectrogram we will get from here. Okay, so this is a MEL spectrogram of each chunks. And if I show you the MEL spectrogram of entire audio, then this is the MEL spectrogram of entire audio. Okay, if you see these two things, then you will see that here we are getting a lot of noise here. Nothing is visible. If you feed this to neural network, then neural network is not able to understand those things clearly. Okay, that's the issue. That's the problem in this audio classification. Okay, so you have to be clear that you are passing a right feature to the neural network. You can't be totally dependent on neural network, that neural network will understand. Nothing it will understand if you will not pass right feature to the neural network. Okay, that's why this feature extraction is very important thing. Okay, so we see that this MEL spectrogram visualization and chunks visualization. Okay, now what we will do, now we are ready to perform data pre-processing. Okay, so first I am doing this, I'm writing all these classes, and then I'm generating this function load and pre-process data. in which I am taking this data directory, and why I am selecting this target shape as 150 cross 150. There is some reason behind that. I am not randomly, like whatever I am doing in convolution neural network, that approach I am not using here. Here there is some reason of selecting this as 150 cross 150, and this reason depends on this MEL spectrogram shape. Okay, this MEL spectrogram, whatever we have generated by using this chunks MEL spectrogram, we are going to use. We are not going to use this entire audio because we have seen that a lot of noise are there. So basically this is our area of interest. Okay, so this chunks MEL spectrogram we will use, and this chunks MEL spectrogram shape is this one. So according to this, we have given this shape as this one. Okay, so there is some reason behind this. I will explain you in detail when we are going to construct this function in upcoming video. Okay, so this entire piece of code I have written to load and pre-process the data, that audio data. This function is returning the data and the label. Okay, so that's this data and label we are storing in a separate variable here. Okay, and if I show you the data dot shape, if I am doing, then if you will see, this is 14,975 and the size is 150 cross 150. So the shape of data is 14,975 and the shape is 150 cross 150. Okay, one is the color, it's not in RGB format, so it is one. Okay, and here we have 14,975 training examples and their corresponding label is this one. Okay, so we have MEL spectrogram and its corresponding label we have. Okay, now we are ready to build some classifier. Now this is the image classification problem from here. Okay, here I am converting it into a categorical like this one, hot encoding I am performing, so that I got this shape. Why I have done this? Because it's needed for our neural network. Okay, we are constructing a 10 class classifier, so that's why we have to construct in this way. Okay, that's why we are doing this. So here we got this much of training example. So we got our labels and we got our data. Okay, now we are ready for training our model. So before training, we are splitting this data set into training set and test set so that we can also validate our model performance. Okay, so this sklearn.model selection we are using, I will explain you everything in detail, don't worry. And then we are building our neural network from here. This is a convolution layer. We are using bunch of convolution layer, dropouts, a lot of things we are using here. If I'm doing here model.summary, then we can see the model architecture. This is a 27.4 MB parameters model. Okay, so this model we are using, and by splitting the data from training set to test set, we got our xtrain, xtest, ytrain, ytest. Okay, so we will use this to train our model. So here we are using this optimizer and loss function, everything, and here we are training our model by using xtrain and ytrain, and we are training it for 30 epochs and batch size is 32, and validation data we are taking xtest, ytest, which we have splitted earlier. Okay, so this thing we are using here, and this entire thing from here, from convolution to down, I have explained in detail in my plant disease detection system. There I have also showed you how we can resolve the problem of overshooting of the loss function, why we are using this much of loss, everything I have explained in detail. So if you are new to machine learning and you don't know how to train a deep learning model, then you can watch plant disease recognition, plant disease prediction system, and fruits and vegetable recognition system. In both of this project, I have explained in detail how we can make an image classifier. So you can watch those videos. Okay, so from here, when I'm using epochs as 30 and batch size as 32, then you will see that after 30 epochs, I'm getting training accuracy as 98.09% and validation accuracy, which is our test accuracy, as 90.32%, which is very good. Okay, and here I have saved this model in both format, this keras format and h5 format. I have seen a lot of comments that some are saying that keras is not supported in my machine, so it depends on machine to machine. Like if I'm saving here my model in h5 format, then I'm getting some warning like your model try to use this keras format, it is good for you. Okay, So you can use, if you are Windows user, I will write here, like for Mac user you can use this one, and if you are Windows user, then try this one. Okay, I'm not sure about Linux, but earlier I am Windows user, so I have used this H5 a lot. But for Mac user, it's showing me warning that use keras file. That's why I'm using here keras file. Okay, so you can use anything. Okay, whatever is supported in your machine, you can use anything, and don't think about size. Whatever is best for your machine, use that one. Okay, so if I show you, like here in my machine, this keras is more compressed as compared to H5, but both are good. If you load this keras, then it will also perform in the same way, whatever you will perform, get the performance of the model on this H5. So there's no issue of size or nothing. Okay, so you can use anything. Okay, so again, after this, I'm printing the history with respect to each epoch, and then I'm recording the history here. Okay, and then doing model evaluation on training set and test set. So on training set, I am getting 99.223% of accuracy, and for test set I am getting 90.31%, which is very good accuracy I am getting. And also I have done a visualization of accuracy and loss. So this is a training and validation loss visualization. So if you see, our training loss is decreasing continuously, and also our validation loss, which is our test loss, is also decreasing. And after this part, I think after 16 to 17 epochs, almost loss is same, so it is saturated from here. Okay, and if we see the accuracy visualization, then for this test accuracy visualization, which is our validation accuracy here, basically it is test set, that's why I am saying test accuracy. So after this 16 to 17 epochs, almost it got saturated, and there is nothing improvement here. Okay, so this is what it's happening. And after that, after seeing these stats, we are also computing precision recall confusion matrix. Same, this and these steps are same whatever I have done in plant disease prediction system. Okay, these are some pre-processing required to generate it in a same format, whatever format is required for this scikit-learn confusion matrix class, and also this classification report class. This required both true categories and predicted categories in the same format. So to perform the same formatting, we are taking some steps here. This steps also I have explained in my plant disease prediction video in detail, but also in this upcoming video I will explain you this entire thing here for this project. Okay, because here use case is different, so I will explain you everything, don't worry. So this is the classification report which we are getting for each classes. Like for blues, precision is 0.94 and recall is 0.86 and F1 score is 0.9. And for classical, this is the precision recall and F1 score, and support is also here. So for each classes we are getting precision recall F1 score by using this classification report. Okay, after that what we are doing, after that we are visualizing confusion matrix. Okay, so this is a confusion matrix visualization which we are doing to understand it better, that by using this confusion matrix we can see that out of how many training example, what are the true categories predicted by the model, and what are actually true categories, and what are false prediction done by the model. Like here, these are, this y-axis denote the actual class and this x-axis denote the predicted class. So this diagonal element are the one which is being predicted by the model and which is actually belong to those, and all the off diagonal are the false prediction. Okay, so if you see for this one, prediction is 22 for, so model is saying that it belongs to 22 training example belongs to second class, but it is actually from 0th class. Okay, so by using this confusion matrix we can make sure about our model, that whether our model is good or not. If it is not good, and if you are thinking that we can make our model more robust, then you have to tune these things. Like you can make your model more powerful by adding some layers and adding all these things, or you can change this audio window from here, chunk duration and chunk overlap. You can change these things. So basically you have to tune two things. First one is this one, to generate a accurate feature for your neural network, and second one is your neural network. So by doing these two things you can come up with some powerful model, but here we are getting 90% accuracy, which is not bad. Okay, it's also very good. But if you want to make a very powerful model, then you can experiment according to yourself. I've given you idea how you can proceed with that. Okay, so this is all about our training music genre classifier. Okay, so in training part we will do this entire thing. So after this you will be able to make any audio classifier by learning these concept. Okay, so this entire concept I will explain you in detail, and once it is completed then we will move forward to this test music genre. Okay, so here we will do a testing of we will take some random audio and we will use our model to perform a prediction. Okay, so first what I am doing here, first I am loading my model, whatever model I've saved here, this one keras or h5, anything. I am loading this model. Okay, and then I am also creating a list of the classes which I have here. So I have here 10 class, so I am creating a list of class. Okay, then I am performing single audio pre-processing, and here also if you see the chunk duration and chunk overlap is same whatever I have used for training. Here for training I have used this if you go in this load and pre-process data, then you will see the chunk duration and chunk overlap is 4 and 2. So whatever you have used for training, use the same thing here also to get a perfect result, because your model is trained on this chunk window of 4 second and overlap of 2 second. So you have to use same pre-processing here also, then only you will get a good result. Okay, this thing we are doing here, and we are extracting the data from here. Okay, like here I am using some I have taken some music from internet, like I've used this Ben Sound is some open source website from where you can get copyright free music. So I have taken some music from here. This music is not belongs to any of the data set. Okay, just to make sure. So let me play this music. Here we are using Librosa to extract Y and this sampling rate from this music. This file path we are passing, and this Y and sampling rate we are going to use to play this music here. Here we are using this ipython.display, this import this audio class we are using to play this music. Okay, this is load and pre-process data function. So we are going to use this function, and we are passing the path of this this test music. Okay, we are passing the path here and extracting the xtest value which is being returned by this function. Okay, so this is our xtest. So we are taking this xtest and we are passing it to our model prediction function. This function also I have developed it. I will explain you and I will write each and everything here. Okay, so at the end of this playlist you will be able to write your own model prediction and your own load and pre-process data function, don't worry. Okay, so this xtest we are passing here and we are performing prediction, and this some computation we are doing. This entire thing I will explain you in detail, don't worry. So at last it's returning me some index. Okay, so the same thing I am doing here. I am recording those class index here. My this model prediction function will return class index, that out of this 0 1 to 0 to 9 which index model is predicting. So model is predicting some class index, and what I am doing, I am using those list, that list, class list, and I am passing that index of this class and what model is predicting. And so if I run this, then it's giving me model prediction that it is rock music. Okay, and here we have used this rock music, and I have also played this for you. So it is actually rock music, and our model is also predicting that it is rock music. Okay, so by doing this entire thing you can make a very powerful music genre classifier. Okay, and once this all training and testing part is completed, I will make a Streamlit web application for this also, just like I have made for my plant disease detection system. I will make a Streamlit web application in which I will pass a audio file, and that app is able to give you a result that in which genre it belongs. Okay, like here it's generating result that it belongs to rock music. Okay, so this is the entire summary of this playlist, what we are going to perform here. Okay, so in training part we will see in detail about Mel spectrogram and how we can do audio pre-processing. This entire thing we will see in detail, and then we will make a very powerful audio classifier using convolutional neural network. Why we are using convolutional neural network? Because here at the end, after performing Mel spectrogram, we are getting image. For image, convolutional neural network is very powerful. So we will use this convolutional neural network to train our model, and here we are getting very good result. 90% is not bad. It is very good for audio classification. And so this is how we are going to proceed in this project series. Okay, and then we'll do a testing, and we'll perform a single audio pre-processing and perform a single audio prediction here. And once it is completed, then at last I will build a web application using Streamlit for this entire project. Okay, so that's all for this video. I hope you like this video, and we'll meet in next video. And in next video we'll start building from this training part. Okay, from here we will start our project, and first we will understand how we can perform audio processing and how we can do a feature extraction on audio processing, and then we will move step by step. Okay, so that's all for this video. We will meet in next video. Thank you guys. Thanks a lot for watching this video.